In this section, we'll talk more about the comparison test. In the first figure, let's compare the partial sum for the sum of 1 over n squared and the sum of 1 over n squared plus 1. So note that here in this case, the sum of 1 over n squared, the term 1 over n squared, and the term 1 over n squared is greater than 1 over n squared plus 1. Right. And this is greater than 0. This meant the sum for n equal 1 to k, the k partial sum of 1 over n squared plus 1 is less than the sum from n equal 1 to k, the 1 over n squared. Okay. Note that this series, 1 over n squared, this is convergent by P series. P series. Now, note here we know that every term of each of these two sequences are increasing and is now bounded above. This means that the sequence here is convergent. Okay, so then the sum at n equal 1 to infinity of 1 over n squared plus 1 is convergent. In second case, we have a monotone increasing sequence, right? Both sequences are increasing. However, note that 1 over n minus 1/2 is greater than 1 over n greater than 0. This means this partial sum is equal to the sum of n equal 1 to k, 1 over n minus 1/2 is greater than the sum of n equal 1 to k of 1 over n. Note that this series here is divergent. Okay. Now, since we have something that is greater than a divergent series, that this is telling us that this sum is also divergent. Okay. So definition, suppose we have two sequences a sub n and b sub n, a series with positive term. If the sum of b sub n is convergent and a sub n less than b sub n for all n, then the sum of a sub n also convergent. If the sum of b sub n is divergent and a sub n greater than b sub n for all n, then the sum of a sub n also divergent. Let's take a look at the first example. Determine whether the series is converged or diverged. So the a sub n term is equal 1 divided by nq plus 3n plus 1. And let b sub n equal 1 over n to the third. Okay, so here in this case, we see that a sub n is less than b sub n. And we know that the sum at n equal 1 to infinity of 1 over n to the third is converged. by P, this is a P series, is convergent P series. This meant that the sum of n equal 1 to infinity, the 1 over n cubed plus 3n plus 1 is also converged. And this is by the comparison test. So here we have the series from n equal 1 to infinity, the ln of n divided by n. Okay, so a sub n equal to ln of n over n. And I don't know whether this series is converged or diverged, or how does it behave. So let's start by writing down a couple of terms. A sub 1 equal ln of 1 divided by 1. A sub 2 equal to ln of 2 over 2. A sub 3 equal ln of 3 over 3. A sub 4 equal ln of 4 over 4. A sub 5 equal ln of 5 over 5. So here I have an ln of n over n. I want to compare this with b sub n, that is 1 over n. So let's write out the term. B sub 1 equal 1, B sub 2 equal 2 over 2, equal 1 over 2. B sub 3 equal 1 over 3. B sub 4 equal 1 over 4. B sub 5 equal 1 over 5. So let's go ahead and calculate the value of a sub 1 and a sub 2 and continue calculate that out, so that I want to see the comparison, what's going on there. So ln of 1, we start here with 0. Ln of 2 divided by 2, this is about 0.35. A sub 3 divided by 3, that is 0.37. Zero point 0.35. Zero point 0.32. So if we compare each of this number, so 1 over 3, that is 0.33, 0.25, 0.2, so note that here we can see that the a sub n is greater than b sub n starting when n equal 3. Okay, so we can see that. Okay, so here a sub n is less than b sub n when n is greater than or equal to 3. And we know that the series for n equal 1 to infinity of 1 over n is diverge. So divergent series, divergent P series. Okay. And since A sub n is greater than B sub n and B sub n is diverged, this implies when n equal 1 to infinity, the ln of n over n is diverged by the comparison test. Let's talk about the limit comparison test. Suppose that A sub n and B sub n are series with positive term. If the limit at n approaches infinity of A sub n divided by B sub n equals c, where c is a finite number and c is greater than 0, then either both series converge or both series diverge. Let's test the series for convergent or divergent. Okay. Here we let A sub n be 1 over 2 to the n minus 1 and B sub n equal 1 over 2 to the n. So let's apply our limit comparison test. The limit at n approaches infinity of 1 divided by 2 to the n minus 1 divided by 1 over 2 to the n, for the limit at n approaches infinity, the 1 divided by 2 to the n minus 1 times 2 to the n this equals the limit at n approaches infinity of 2 to the n divided by 2 to the n minus 1 equal the limit at n approaches infinity of 1 divided by 1 minus 1 over 2 to the n. This is 1. It's a finite number greater than 0. Therefore, the series of A sub n converge by the limit comparison test. In the next case, I need to make a decision. How do I pick the series for B sub n? Well, I know that A sub n equal 2n squared divided by square root of 5 plus n to the 5th plus 3n in the numerator. Now let's say as n get bigger, the numerator B sub n, the numerator would then behave like 2n squared, and the denominator will have to behave like n square root of n to the 5th. Let's go ahead and simplify this. This is 2n squared divided by n to the 5 over 2. And this is 2 over n to the 1/2. So let's go ahead and do the limit comparison test. The limit at n approaches infinity of A sub n, that is 2n squared plus 3n, divided by square root of 5 plus n to the 5th, divided by B sub n, would mean multiply with the reciprocal. This is n square root of n, or n to the 1/2, divided by 2. Okay. So let's multiply this out. So I go ahead and divide the numerator, both numerator and denominator, by n to the exponent 5/2. Then I get 2 plus 3 over n divided by 2 times square root of 5 divided by n to the 5/2 plus 1. Because I squared and bring it inside, so this is n to the 5th. Okay. As n approaches infinity, this term go to 0. This term also go to 0. So then I have 2 plus 0 divided by 2 times square root of 0 plus 1. This make 1 greater than 0. Therefore, the series a sub n is convergent by the limit comparison test. Okay. So some key thing though, in this case, I happen to give you the series that is increasing, right? And it have positive term. You have when you are given a series, you have to make sure the condition of the limits comparison test satisfied before you proceed with the test. So in other words, you have to make sure this is the series with positive term. Okay.